So let's continue our discussion around F5 DNS deployment strategies. Okay, so we'll stay on Objective 103. This is going to be part 2, in which case we're talking about big IP DNS features. Alright, so as we switch gears from the architecture, benefits, and designs, we're going to go into the big IP DNS features and talk about the use cases for that. Start with DNS Express, Zone Runner, the GUI management system, DNS64, the IP6 to IP4 translations, DNSSEC providing additional security around DNS, DNS caching can improve or can decrease the latency in your environment, the DNS load balancing algorithms such as topology, return to DNS, and then DNS persistence and DNS health monitoring. So let's dive in. Okay, so let's talk about our first use case feature for F5 Big IP DNS. So we're going to talk about DNS Express, and there are two flavors of DNS Express. There's off-box bind and there's on-box bind. In this case, we'll look at off-box bind. So DNS Express, why you would want to use it is it basically acts, it puts your F5 as a high-speed authoritative secondary DNS server. So we're basically sending the zone information from the internal DNS server to the F5 DNS server, and now all the requests are going to be handled by the F5 DNS. So requests from the inside will just be used for management purposes. So if you have a robust management tool for updating DNS records, you could still use that and then have that act as a hidden master, and then use what the F5 DNS can be really good at, is responding to requests faster. So DNS Express specifically puts these records inside of memory in the F5 DNS. So you get a low latency response, and you also are able to serve DNS requests a lot faster, which mitigates DDoS attacks and offloads requests to the servers. So let's take a look at the step-by-step process for implementing this, and then we'll take a look at a live example. So step 1, we define the off-box bind name server in the F5. So it's basically a IP object that references our internal DNS server. Next, we'll create a zone. Now we can choose a zone that we want to pull from the internal DNS server. So in our specific example, we're going to be using f5demo.com zone. So the requests are then taken from that zone and put automatically inside the DNS Express database. After that, we'll want to verify that the DNS profile attached to the TCP listener is enabled for a zone transfer, and then the UDP listener also accepts DNS Express. Okay, so let's take a look at the flow. So first, the F5 DNS can be used to send a zone transfer request, and a TSIG key is optional to hash the data and then use the key to unencrypt it. So it prevents somebody spoofing different zone transfer request information to the F5. So we will configure a zone transfer, and this is done automatically after you create the zone. And the source is going to be the F5 DNS self IP. The destination is going to be the internal DNS server. Okay, so if the internal DNS server has the allow transfer statement and allow notify message, and it's allowing these two destinations, or this is a destination, this would be this is the source, allow transfer, and then allow also notify would be the destination. So if that's correct, then it will send or approve that transfer request. It's called an AXFR notify update message to the F5 DNS listener IP address. Okay, so that's a continual process. Now there's a refresh interval that's used, so if you make a change on the internal DNS server, F5 will check based on a refresh interval or serial number of that zone data, make sure that it's up to date. Okay, so a normal A record request comes in to the LDNS server to the F5 DNS boxes, and now the F5 DNS server will respond to that query using F5 DNS Express. So it's an in-memory process for a faster response time and allowing for DDoS mitigation techniques. And the LDNS server will send it back to the client as normal. So now let's take a look at an example so you can see the process a little better. Okay, so we'll start the process to create a DNS Express off-box bind scenario. So first we go to the DNS delivery name servers, and in the name server list section we would create the off-box bind name server. So we'll just call this f5demo.com as our name server, and we'll give it the IP address 10.1.20.252. Service port is going to be 53. Route domain 0 tsig, we'll keep that at none for right now. Alright, now that we have the name server created, we'll create the zone that we want to pull from the off-box bind. So we'll go into the zones, zone list, and create a new zone. And this is going to match f5demo.com. And the server we're going to use is f5demo.com. We're going to enable the state. The notify action is going to be consume. And in the help section you can find the notify consume allows DNS Express to generate that response. So it's approving the listener to consume that record that we received and basically take place of that DNS internal server. Okay, the allow notify from is going to be the same name server address we used to create. So we'll give 10.1.20.252. Okay, and we'll pull in the name server f5demo.com and click finish. Okay, I think that was I clicked finished and I clicked it again, and I think it was that second one. So it ended up creating it just fine. Okay, so you can see right here we've got a successful transfer, zone transfer request, and let's look at the CLI. Okay, the actual zone transfer request log will show up in LTM, as you can see. Okay, so this is just that generic message, but before that happened, we had a zone transfer request for f5demo.com to our name server in the back end, and it succeeded. Okay, so that's good news. In order to see the actual records that the DNS Express now has loaded in its system, you can use the DNSX dump utility, and we'll just pipe for less. So now you can see in the region stats, you'll see how many objects are served in memory on the F5 platform. So we've got 244 objects. And then a database dump will show the domain and all the records associated with it that's now loaded into memory with DNS. The DNS stats gives a nice summary of how many A records have been populated from this zone, the name server records, and the start of authority record. Okay, now let's take a look at the actual bind server on the back end. So I wanted to show you where we're actually pulling the bind database. Right, so we've got in Etsy bind zones. Now this is an Xubuntu box, and you'll find this in a similar place on most Linux platforms. So we go into this directory and do an ls, and we see that f5demo.com.db. So we can cat this file to see. Let me do a copy paste. Okay, and we can see all those records that are now loaded into the F5 DNS platform. So if you had like I said, a robust utility that you use to update your bind servers or a management tool, that you can continue to use that, and then the F5 will constantly check via refresh requests if it's up to date. Right, so these same records are now pre-populated into the F5 DNS platform. Okay, and so remember that place where we define the allowed transfer and also notify. I'll show you where that would be placed in that system. So let's go to, it's going to be in, go to CD Etsy bind, do an ls, and we see the name.conf file here. Just do a cat paste. I got to do a copy first. Let's just do this. Okay, so we notice that these are really comments, and then we've got some include statements, but we don't have an allowed transfer and also notify. So if you don't, it'll automatically accept any IP address. So if you did have specific IP addresses in those statements, which is a good best practice in a production environment, you would put the F5 DNS self IP as the allowed transfer statement and include the F5 DNS listener as the also notify statement. Okay, so now that that's working and we have a successful zone transfer, let's actually test this and verify it's working properly. So you can do a DNSX dump again to see what we can use to test with. So we've got 37 entries in here. Let's use the IAP. We could do a DNSX dump and grep for IAP. Okay, so we see that it's 10.1.10.40 is the IP address that's loaded into DNS Express. So let's jump to the CLI of my Windows client. So this is going to act as basically an LDNS server because we're pointed directly to the GTM listener. So we can do a dig to the GTM listener for iap-f5demo.com. Before we do that, we'll look at a TMSH command you can use to show the stats for the zone. So you could do show LTM DNS zone and then f5demo.com, the name of our zone. Okay, you can see we've got it's currently a successful zone transfer. We've got the 37 records showing up in our LTM zone DNS zone. And currently we don't have any query messages coming in. So let's go ahead and go back to the client, and we'll hit enter here. Okay, so in our answer section now we see that 10.1.10.40 address show up, and who's authoritative for that zone. on the inside, which is actually interesting because we'll see the real hidden master here, the lamp2.f5demo.com, and where that is currently the name server of that zone. Okay, so let's go back to that show command, and we see our first query and our first response from that. We got no error here, and we had done a zone transfer request earlier, so you don't see that listed here because I did have to reset the stats, and just to make it a little cleaner for you guys to see. You can reset the stats by doing reset stats, or let's do an up arrow, and we'll type in reset stats and go back to show, so we can see 0 again. But that allows you to see, obviously, if DNS Express is working for the clients in general, and you'll see the serial number associated with the start of authority, which is the hidden master. So this, if you wanted to do just look at the serial number, you should see this serial number change every time you make an update to your internal hidden master server. Okay, so let's take a look at the next example for DNS Express, the on-box bind. So this is where we don't have the internal DNS server anymore. Now the F5 DNS is acting as the on-box bind and DNS Express. So let me walk you through the steps. So first we're going to define the on-box bind name server as the big IP, so it's the loopback 127.0.0.1. We create the zone for DNS Express, and then we're going to add option statements for the local host, allowing the update, allowing the transfer via the local host, and then also notify is basically saying I want to take the 127.0.0.1 from Zone Runner and allow that to update the DNS Express database. So the zone update request happens from the source again, and this is actually in Zone Runner, and it's in the var named config named b directory, or namedb directory. And let me actually show you. So we have in this directory list all the name records, or the database records in bind. So if we wanted to look at a specific record, like for that F5 demo, we could cat this file here, and you'll see all the records associated with that zone. If it's authoritative for that, you'll see the records for that via bind. And you configure this all through the Zone Runner GUI, which is incredibly nice. You're not updating all these bind files manually.